G'day guys, Mac with the Outer Circle. In today's episode, we're going to be looking at basically mold making principles to try and talk about what happened with the Epic / Legions Imperialis, still a dumb name, and how basically mold design constraints affect the way we actually create the miniatures on the sprues, which explains how the Marines turned out the way they did with those big dags of plastic. And what the actual remedy is to it, because there is a remedy, you can mold them in that way, it's just more difficult. So, what we have here is basic shapers. So basic shapers is, well, it's exactly what the name implies. It's perfect cube. Now, when we make this perfect cube, and we want to mold it, basically we need to create a negative. So, injectus and ejectus. Now, injectus is the fixed side of the mold. The injection point here is where he gets his name from. And on the back, we have the ejection side. So little pins or compressed air goes through these holes, and it will push the finished part off. So this is our basic mold. So if I select either one of these molds, and I want to keep my tool, which is going to be basic shapers, I can actually cut basic shapers out of each of these halves. And when I hide the bits I don't need, you can see the basic shape in the mold, nice and easily like so. Now we've got to make sure, obviously, that this injection point comes into the part we're creating. And we have to make sure that on the injection side, on the ejection side that is, that we are able to get our ejection positions in line with where the part is so that we can push it out. Now, you would tend to not create sharp edges if you could. You would try and round out the edges, fillet it like so. But we're not doing that here. We're talking the basics. So let's go back a couple of steps here to before we cut the shapes out. What if I were to modify this part? Let's say I create a V. Let's cut a slot in this. So from there to there, and we're just going to slice this big old V out. Now, remembering our position of our mold, injection and ejection, fixed and moving, how is this going to affect it? Is it still going to work? Well, let's find out. The answer is yes, but we'll have a look anyway. Alright, so if I remove these parts, you can see that even though we've cut that big V, yes, the plastic is still able to get in, and there is nothing that overlaps or anything like that, so we can easily take the shape and we can pluck it out with ease from our mold. Okay, good. What about on the other side of the mold? Do our 4 ejection pins still work? Yes, they do. So all of this is fine. Just walking back the steps. Now, what if I were to take this part and rotate it 90 degrees around? Would this still work? Well, let's have a look. So, inject, eject. Let's cut the shape out, and let's have a look what happened to our injection side. Now we have this massive overlap. And, well, you can't get a physical object, like basic shapers here, out. You can't pull him out without him having to physically go through or deform or break off or snap. So this is no good. We can't do it. So, okay, we can't do it that way. What can we do? Well, we could rotate basic shapers here again to try and make this work. So we're going to rotate him over 90 degrees another way. And then let's cut the shape out again from our mold. And, well, okay, we can grab him and pull him back. That works. But have we created any other issues? What about the injection point? Well, because I put the ejection point off center, up high, that's fine. But if it lined up with the edge of this little deformation I've now made, the V, then part of the ejection point that goes solid in the end here would be stuck, and that would cause another type of jam. So this shape works currently. But what if I were to make a more complicated shape than even this? What if I were to take this shape here and I wanted to put a hole through it? So we'll do that now. If I pick a hole, I'll put it right in the middle, and let's go 10 millimeters. Nice small hole. It's only a little 50 by 50 cube basic shapers. And I put that hole clean through him. And then I put my ejection side on there. You can see it without me even doing anything. There's going to be material inside this hole. So let's cut that out and have a look. And we'll do it with all three parts here. So cut out the shape of basic shapers. Like so. And now you can see, if I was to remove basic shapers from there, we have a problem. We've just put a massive retention pin through the middle of our die. So this is pretty important now, what we do to fix this situation. Now let's head on over to Crudius Spaceyboyus and his Crudius Armus. And you see the phenomenon right here. Now, this very crude representation, believe me, I can sculpt. I just chose not to because I don't need to sculpt anything serious for such a informational video. This hole through the middle of his arms and this negative space between the magazine and the body, as well as, to a degree, these little slots behind the back of the miniature, behind the nacelles and that, they're all points where, if I try to pull this miniature out of the mold, we're going to have an issue. So what can I do with this? Well, there's a few approaches I could take. I can take apart and I can reorient it. Put the bolt gun, say, hard across the chest like so. And now, well, I can mold it side on. There's nothing that's going to catch from the top or the bottom. All right, we're back in business. But that's obviously old school Epic, that's exactly how they molded them. It's crude, but it's effective. But it doesn't mean you get dynamic shapes. So if you want to maintain this shape, there are two approaches. Either you fill in the holes with solid material, which is what Games Workshop elected to do on their mold, which is why the Marines have those horrible looking dags. They are not a design defect, they are a design limitation. So they would take a section that's going to cause issues and they fill it in like so. Again, this is a very, very crude example of that. But now, if you fill in that, and then you fill in the air void in the hole in the middle left over, there is nothing here that can now jam in the mold. That's the theory behind it. But thinking back now to Injectus and Ejectus, these designs over here, is there a solution to the problem? Well, yes, there is. So what the solution is to look at our basic shape here, and essentially, we cut a hole out of the mold. Again, this will be quite the crude hole that I'm going to cut here. But if we were to cut these sections of mold out, like so, it would expose the center. So we have to get rid of that pin, right? So now you can see what needs to be done. So we create a new object. We create a new body here. And this body will go all the way right into the middle there. So we need to make something that comes this far into the mold. Right into this point here. So that's where we're going to start. Now from there, I'm going to come out a few millimeters. And then, well, we can come straight back. It's actually quite a simple cut we're going to perform here. So we would cut it like so, okay? So think about that for a moment. I'll create a copy of this just so I don't lose it. Get out of the way, spare injectus. And I'm not drawing this in the best way I could or should, but whatever. You guys will get the point when you see it done. Alright, what we've now created is what's called a core. Now, this core is not perfect because I've got this little piece in here, right there. That we don't want nor need on the end of our core. So that boy there we'll get rid of, okay? But just for the sake of the video, we'll leave it there. But what we have now is we have the injection side of the mold, and we would have this plate would basically double over. So we'll do that. Create mirror of that. And then cut the shape out. Okay. So now what we have is we have the moving side able to move in and out of the part. And what we've created, this extra section, is what we call a core. And the core moves in a third dimension to the rest of the mold. So again, ignoring the fact that I've cut it in such a way that I've still got this little triangular peg on the end. Normally it would just be the round part here in this particular type of core. But we can now create a complicated shape in multiple dimensions. So as the die is actually in operation, the first thing that would happen when we create the part is this side would come in, close up like so. Then after that side is closed, this part will then move in like so. We cast the part, this pulls out, and then this side pulls out. And then the part, which is trapped on this side of the mold, gets spat off. Basic Shapus gets spat off out of the mold. And that's how we create more dynamic moldings. So in the case of this Space Marine here, what could have been done? Well, they could have had a core that came in, say, from the top. Something like a triangular shape that went down and filled this space in here. But there is a compromise to that, because if you do it, well, one, it's hard to lay out, especially with the really, really tiny parts you would need to make that core out of. But the principal limitation here is price. Because if this die is a $60,000, $70,000 die that we created, how much extra cost do you reckon we're going to add by adding a core? And it's not as simple as being the same price as either one half, because all of the mechanics to make the core work, the hydraulics, the pneumatic systems, the sensors, the extra programming that tell it to move in and out at the correct times, that's additional cost. So it basically doubles the cost of a die, as a bit of a rule of thumb for those of us in plastics. So this is the situation that led to the Marines having that ugly little dag or tag or whatever you want to call it on them. It was a limitation of what they were trying to create, meeting injection molding resources. Now, as for the multi-part tanks, and having to put like 10, 12 parts together for a single Rhino, that's just down to bad design as much as it is to limitations of the materials. They could have done it more easily and simply. They chose not to for a variety of reasons. And one thing to point out with that is you can't just take 28mm scaled parts, like 28mm scale tanks, and shrink them down to 8mm. It doesn't quite work like that, because there are a lot of details that just don't translate in scale swaps. If I take a Marine, and I'll use this individual here for example, right? If I take that guy and I rescale him, how crude do you think all of these horrible curves and sharp edges on him are going to be now that I've blown him up to 9 times 900% of his original size? Versus when he's, tiny little man down there, his original scale, you can forgive a lot of those blemishes. So you have to amplify some aspects of the design when you shrink them, and you have to remember that some things are just going to be lost. So on Marines, they try and keep things like, okay, basic shape of pauldrons, trim, head, bolt gun, but they're not going to blow into the bolt gun and go, alright, let's put the magazine release catch onto the bolt gun. It would be pointless to sculpt it and to try and machine it. It would be a waste. It'd be too small a detail. And don't forget, another limitation of creating these items is the minute you start injecting the plastic, it is already cooling down. So we have to use things like hot runner systems where we keep the plastic heated as it travels through the die. But getting all of the plastic into all of the nooks and crannies is especially difficult, and again, a design limitation when you're creating something the size of an 8mm tall Space Marine. Anyway, that's it for me. I'm Mac with the Outer Circle. I hope I've shone a little bit of light on this situation, and please, if you've got any comments, hit me up. See you on the next video.